Hello everyone, I welcome you all, and in this video we are going to discuss the numerical from your unit number 1, that is vector analysis, and this numerical is basically related with the vector algebra. Okay, so if you have any queries you can drop me a mail onto my this email ID and I will try to get you back as soon as possible. Now we will begin with the very first part of the numerical, where we have to find out the vector projection of vector S onto vector T. So we will find that one. Now in the very first part of the numerical, we have to find out the vector projection of your vector S onto vector T. Vector S onto vector T. Okay. So what will be that vector projection? So your vector S will be as it is. Then we have to take the dot product of this vector S with respect to the unit vector of your second vector, that is vector T. So unit vector of your second vector, that is vector AT, and then we have to multiply it again by using the unit vector of your second vector, that is vector AT here in this case. Now if they have asked us what about the scalar projection, so this component is said to be what? A scalar projection of your vector S onto vector T, or you can say what? You can also say it to be this as a scalar component of vector S along vector T. So this is what, and if you have asked about what is its a vector projection or vector projection will be what now? So that will be the product in between the scalar projection or component into, see, this is not a cross product, into unit vector of your second vector. Okay, fine. So here in this case, we have been asked just to find out the vector projection of S on T. So we will be finding that vector projection of vector S on vector T. This is for your just reference purpose. So I am going to rub it out. Okay, so before moving on to finding out that vector projection of vector S on T, we will find what is the unit vector AT. See, this is not very much difficult, but if you don't do this, the things will seems to be very messy while solving this. So, in order to keep it simple, very firstly we will do what we will do. We will find the unit vector along T, and then just we are going to simply put that values over there. Okay, so very firstly we will find what is unit vector T. So very firstly we will find what is unit vector along T. So for that purpose, from the basic definition of unit vector, what we have, given vector T divided by its magnitude will be your unit vector along T. So what is your given vector T? We have that value given as 2ax cap minus 6ay cap plus 3az cap and divided by its magnitude. So what is its magnitude? So that will be square root of this 2 square plus minus of 6 square plus this 3 square. So this is your magnitude of T, and we will be keeping this numerator as it is, that is 2x cap minus 6ay cap plus 3az cap, and if you simplify this square root of the denominator, you will find that value to be what? 7. So this is what we have, the unit vector along T. Now we will be finding what is your vector projection of S on T. By keeping that values over there, we will simplify that one. Now we are going to find the vector projection of vector S on T. We have the value of that AT. Now what is your vector S, which is given in your numerical? So we are going to write that one. Vector S is what? We have that value to be ax cap plus 2 ay cap plus az cap. Okay. Now having the dot product with respect to your unit vector along T. So what is your unit vector that we have found over here? So we are going to place that value. Okay, so we have that to be 2ax cap minus 6ay cap plus 3az cap divided by 7. Then complete this, and then again we have to multiply it by using what? By using your unit vector 80. So we are going to multiply that one. So that will be what now again? See, if you are enough expert within calculations, you can get the values of that denominator and numerator in terms of some decimal point, and then multiplied by that unit vector with respect to your vector s. And if you want to keep this uh, simple, so you can go with this method. So based on your practice and expertise, you can simplify this numerical. Okay, so I am trying to keep it simple as possible. Okay, so have that dot product very firstly. So we are going to solve this curly brackets. So from the property of dot product, what we have? Ax dot ax equals to 1, and what is magnitude? This 1 into 2. We have that value to be 2. Then this 2 into minus 6. So that will be what now? Minus 12. This 1 into this 3. So that will be what now? That will be plus 3 divided by 7. So this is your very first bracket, and within your second bracket you will have your unit vector 80 as it is. So that is what? 2ax cap minus 6ay cap plus 3az cap divided by 7. Now we are going to simplify that one. So your very first bracket will be what now? Minus 2 plus 12, sorry, plus 2 minus 12. So minus 10 plus 3 will be minus 7, and minus 7 divided by plus 7. So that is what? We have minus 1, and keep this second bracket as it is for now. Now using calci you can find out the value for that 2 by 7, then minus 6 by 7, and this plus 3 by 7, which is in the denominator, so that you will get the value of the vector projection of vector s onto vector t. So if we simplify that one, you will find your vector projection of vector s onto vector t to be with this value, and then multiply it by using this minus 1. So you will find that value to be minus 28, 57 ax cap plus 0.8517 ay cap minus 0.4285 az cap. So this is your very first part of the numerical, where we have found the vector projection of vector s onto vector t. So I am not going to write that one. You just refer what is given to you. Okay, sorry for this. Okay, so this is what? Vector projection of vector s onto vector t, and we have this value. Okay, now we will move on to the second part of the numerical. Now in the second part of the numerical, we have to find out the smaller angle in between vector t and vector s. So either way you can make use of dot product or cross product. So here in this case I am going to make use of the cross property of the dot product. So what we have from the property of the dot product? So the dot product in between your given two vectors is equals to what? The product of the magnitudes of your respective given vectors and the cos cos angle of the in between them, cos theta of the angle in between them. Okay, so from this one you can find out the value of the cos of the theta in between your vector s and t, which will be equals to what now? Your given vector s having dot product with respect to given vector t divided by the magnitude of vector s and the magnitude of vector t. So this is what is your smaller angle in between the given two vectors. So put the values of that vector s. So we have that s is equals to what? Ax cap plus 2ay cap plus az having the dot product with respect to your vector t, and that vector t is what? 2ax cap minus 6 ay cap plus 3 az cap divided by the magnitudes of the respective vectors. So we have the magnitude of your very first vector to be this 1 square plus 2 square plus 1 square, and what is the magnitude of the second vector? So that will be 2 square plus minus 6 square plus 3 square. Now simplify that one so that you will get answer. So very firstly go with the numerator. So dot product in between the two same vectors is 1, and what about that magnitudes? So 1 into 2 is what? 2. This 2 into minus 6 will be minus 12, and this 1 into this 3, so that will be what? Plus 3. Now very first square root after simplification you will find that to be a square root of 6, and your square root second square root, so that will be what now? Square root of 49. Now if you simplify that one, so you will find that cos of the theta in between s and t is equals to minus 7 divided by 17.414, which will be equals to what? Sorry, there is something missing over here. 17.14, and its further simplification, it will give you the value of minus 4084. Now this is what? This is the cos of the angle in between your vectors s and t. Now in order to find out that theta value, so that theta is equals to what now? Theta st will be cos inverse of your this minus 4084, and if you take the cos inverse of that value, so you will get your answer. So we have, after taking that cos inverse of 0.4084 minus value, so we will find that theta st is equals to 114.10 degrees. So this is your final answer of your given numerical. Okay, now you can hit the like button if you appreciate my efforts. Okay, thank you.